The emergence of real-time data has transformed a number of industries. But what can we actually do with it? For Tech Republic and ZDNet, I'm Dan Patterson with ZDNet contributor George Anadiades. George, real-time data has transformed a number of industries. Obviously, we talk a lot about artificial intelligence and machine learning, but IoT is also a big part of real-time data, as well as a lot of the applications we take for granted and use every day. So I wonder if you could introduce us first to the concepts, the technology behind real-time streaming data, and then maybe provide a few examples of how we use it every day.
Mm-hmm. Yeah, sure. Actually, IoT would be a good starting point since you mentioned that, and it's one area, one domain that's very typically associated with real-time data and streaming data. And the reason for that is that, well, basically, IoT is about having all these devices and all these sensors actually that don't necessarily have to be attached to the device, but you have devices and sensors that generate data at real time. So there you go already by definition, you have real-time data. But it's actually not the only area in which you have that. It's the archetypal example, let's say, but finance is another one. So, because you have all these financial applications in domains where the need for speed, as we say, is really, really important. So it really makes a difference in terms you can lose or win millions of dollars depending on whether you are able to act on the millisecond level even, in things like high frequency algorithmic training and so on. So these are the areas that have been driving the applications for those. But now we see that this is expanding to other domains as well. And one example that many people will be more familiar with is, for example, that has to do with consumers, advertising. So we have been seeing the rise of programmatic advertising. And what this means is basically that, well, instead of having some human agents, let's say, determine which advertisement gets placed where and, for what money and under what conditions and so on, increasingly, this is happening automatically. And in the backend, this utilizes real-time data. So, for example, if you're browsing around a website and you take some action, I don't know, click here or there or load a web page and so on, if you are able to collect that data, that streaming data in real time, and process that in real time, that will influence the kind of advertisement that you will be shown next. And so, in order to do that, you need a certain number of things. So, and some of that have to do with infrastructure, and some other has to do with, well, technology and concepts and platforms. So, the infrastructure, some of it we already talked about. So you have things like sensors or, well, websites, and generally anything that can, or mobile devices, even anything that can generate data in real time and in large amounts, because that's also important. And then, well, you have things like storage and compute and bandwidth, all of which, the capacity for all of which has been exploding lately. So the basic ingredients are there, which takes us to what is perhaps a more interesting area. So how does it actually work behind the scenes? What do you have to do to collect all that data and do useful things with them? So we have been seeing a number of platforms emerging there, what people refer to as streaming platforms or real-time platforms. And it's interesting to contrast that with big data, because traditionally when we talk about big data and things and platforms like Hadoop, for example, these are all based on batch processing paradigms. So the idea is there that you collect loads and loads of data, and then offline at some point you process them to get insights. Real-time data processing takes this to the next level, let's say. So yes, you keep doing that, but in addition to having your batch processing, you also add real-time data processing, and the combination of these two enables you to derive better and faster insights, basically. And there has been a number of architectures that enable people to do that. So there is the so-called Lambda architecture, which is basically precisely about that. So having two different sets of data pipelines, one for batch data, offline data, and one for real-time data. And this works, but it, of course, as you can understand, if you have to implement the same thing twice, it makes it cumbersome, it makes it costly in terms of both infrastructure and time and energy you actually have to spend on keeping these things working and in sync. So people have been trying to, as we say, squash this Lambda architecture in the new type of architecture, which is called Kappa. And Kappa is basically all about having the same kind of processing happen on both your offline and your real-time data, ideally using one platform to do that. And there has been a number of platforms that have been emerging in that space. So the typical entry point has to do with, first of all, you have to deliver data. And that comes with some semantics attached. So when you basically, and this has actually to do with a concept that has been around for a while in messaging systems, for example, when you basically break up your continuous stream of data into packages that you can handle. And well, one of the basic reasons for doing that is because you want to add what we call delivery semantics. So when you have a stream of packages, and that actually also happens, by the way, on the internet, on the web. So, for example, we're talking now, and it's a streaming experience, right? It's uninterrupted. But what happens in the backend is that, well, all these chunks of data are broken down into small packages, which are delivered one by one. And what happens is that the recipient of these packages has to assemble them and put them in the right order. And, you know, eventually these packages may get out of order or they may get lost. So you have to have mechanisms in place that ensure that even if these things happen, you will be able to reconstruct your original stream. And this is the delivered part. It has been around for a while, but, well, as we mentioned now, the scale basically and the demands is on a different scale. And then there is the processing part, which is basically about what you are going to do with all that packaged data that has been broken up into packages after they have been correctly delivered. You usually want to have some sort of selection mechanism there that will enable you to see basically what goes where. Most of these platforms, these real-time streaming platforms, do not have a backend storage of their own. And if you think about it, it makes sense. I mean, we're talking about enormous volumes of data. So what they typically do is they delegate to some other existing solution, like NoSQL streaming, NoSQL scale-out database.
So, George, I know that Amazon, Microsoft, and Google all have their own individual real-time data streaming platforms. How are each of these big tech companies' platforms different?
That's a good question. Actually, in order to fully answer that, we have to also consider the strategy of each of these really huge vendors. So Amazon, for example, it's the leading cloud platform, and so they're not really that much interested in in collaboration, let's say, and cross-platform portability and so on. Actually, it's in their own best interest to keep their users as much locked in as possible. And then you have, for example, Google, which is a contender in the cloud. I mean, Google is huge, but in terms of cloud, it's dwarfed by Amazon. So, by contrast, it is in their best interest to try and, let's say, lure users their way by offering a certain degree of portability. And this is actually the reason why they have come up with something called data flow. Dataflow is a Google solution in this area, as contrasted to Amazon's, which is called Kinesis. And the interesting thing about Dataflow is that it's the basis for a whole, well, it is a platform, a solution in its own right, but the principles, let's say, behind that have been extrapolated, have been abstracted, and there has been an API that has come out of that and subsequently donated to the Apache Foundation. The Apache Foundation is probably the most well-known open source foundation out there. And so Dataflow has formed the basis for what is now called Apache Beam. And the idea there is that, well, you have Apache Beam, which is like the abstraction, and then you have Google Dataflow, which is one implementation. And then you may also have other implementations, and the idea is there that you can take your code that is meant to do real-time data processing and run it on whatever back-end engine. It may be Google Dataflow, and there's also other implementations. One of them, for example, is Apache Flink. It's a different type of engine that essentially lets you perform the same kind of tasks as Google Dataflow. And the interesting point there is that because there is compatibility between these two via Apache Beam, it means that you can take your code and run it on any of these platforms. There's also other platforms around, like Apache Apex, for example, and probably the most well-known that beyond the big cloud players that people use in this area would be Apache Spark. Now, for all of these Apache projects, there is also typically a commercial entity behind them that works, well, you have the open source version, and then you have a sort of managed version that runs in the cloud and also has proprietary extensions that let you take care of things like governance or scaling out and this type of thing. And the same is the case with Spark as well. So the people from Spark, for example, say that, well, we're not really that interested in supporting Beam with the common interface that we talked about, well, because we have our own solution there, which we believe is better in a number of ways. And so you see this kind of tension beyond portability on the other hand, and, well, innovation and differentiation on the other hand.
George Anidides is a contributor for ZDNet. You can read all of his posts about big data, artificial intelligence, and the future of machine learning by visiting ZDNet. And while you're there, make sure you subscribe to the Tech Today newsletter for Tech Republic and ZDNet in New York. I'm Dan Patterson.